Manufacturing Insights, Manufacturing Engineering Magazine's video series for process improvement. This program will explain how value stream mapping, also called material and information flow diagramming, is being used to improve the manufacturing of gas-fired stoves at Yodel North America in Gorham, Maine. During a two-day training event, employees at Yodel North America examined and documented the process for producing their world-famous stoves to systematically identify unevenness, delays, and correction loops in both material and information flow. Then, using the standard value stream mapping symbology, they envisioned and depicted an improved flow of material and information for the stove line based upon lean countermeasures. The team of employees documented the current material flow on the shop floor as well as the flow of information that controls the production operation. In doing so, they uncovered opportunities to improve quality, cost, lead time, and customer value. The value stream mapping effort was led by Pat Wardwell, Senior Continuous Improvement Manager for Greater Boston Manufacturing Partnership. Pat's role was to help Yodel build a synergistic team. As facilitator and motivator, she helped them to see and then communicate improvement opportunities using the symbols and terms of value stream mapping as they created current and target condition value stream maps. In the next few months, the team will work with others in the company on the opportunities discovered through this typical value stream mapping exercise. To begin, Pat reminded participants that continuous improvement is for every employee. She explained how the value stream mapping tool enables them to map current and target conditions, encouraging them to share their knowledge of problems and their creativity for improvement. Pat outlined how the tool of value stream mapping would allow them to step back and examine the overall flow of material and information. They would discover just how well value is flowing according to customer requirements. Moreover, she stressed that it accomplishes this by engaging and sharing the thinking of every single employee involved in the value stream. Then the team was reminded about the definition of waste in a process and how the map would illustrate the problems that come up when material and information are not flowing. Next, they learned about the various symbols used with value stream mapping. It was explained that the symbols represent a common language for communicating process flow and impediments to flow. In this sense, the value stream map is a visual standard that strengthens company-wide understanding of improvement opportunities. The team then studied the key measurements included in a material and information flow diagram. They were introduced to key data that would be needed to be captured and quantified within the current state map. Next came the go-see phase, where the team went to the stove production, shipping, and supporting areas to see firsthand how material and information was or was not flowing through the Yodel plant. This phase provided the inputs necessary to draw the current state map. The team was able to capture many potential improvement opportunities along the way. The shop floor walkabout is critical in a value stream mapping exercise. It is the key to developing tacit learning for everyone involved. In fact, if the process does not involve direct observation, the exercise will be superficial and counterproductive. Seeing the process firsthand allows the team to understand all the steps that have to be coordinated and synchronized for a customer to get the right stove at the right time and in the right quantity. After acquiring a common and fact-based understanding of how things were happening today, the team worked together to make plans for a better process. The target condition was envisioned and defined using the value stream symbols. The final hours of the training session focused on making a plan to achieve the target condition. This video also includes additional insights from the event facilitator, Pat Wardwell, Brett Watson, the president of Yodel North America, and Scott Clinch, the manufacturing manager who will work together with his people to make many of these proposed changes. For more information on value stream mapping, check out the book Learning to See, published by the Lean Enterprise Institute. Today's business climate mandates that companies stay focused on the customer. Successful organizations make sure their customers are treated as number one. They understand that the customer is the one who sets the price and decides what they are willing to pay for. To stay ahead of the competition, a lean company must be able to respond quickly to both internal and external customers. Employees at Yodel have been involved with continuous improvement for several years. They have built thousands of stoves and understand how value is created from what they do. However, Yodel employees recognize that their processes are still far from perfect, and that within every operation, there's always room for improvement. Employees still share some dissatisfaction with how things are being done. This dissatisfaction is normal and is a necessary condition to foster the improvement spirit. To best observe the manufacturing process for a stove, the team took the same journey each stove takes as it moves through their facility. By directly observing the work being performed and talking with the people doing it, they gained an understanding of the entire process. To move from the current value stream flow to where the company wants to be tomorrow, Yodel is planning on making a series of adjustments to its assembly line and the production planning process. The Japanese term for these changes is Kaizen, which means good change. Each change will eliminate various types of waste and make Yodel more productive and better able to serve its customers. The majority of improvements planned do not require additional capital investments. In most cases, a company already has all the machines and equipment required. The only thing changing is how the process is being done, to eliminate waste and make more time for value-added work. While planning for value stream improvements, everyone should be encouraged to think of reasons why the new way will work, not how it will fail. Also, don't spend too much time making the value stream perfect the first time. Value stream mapping is an iterative process. At some point, today's target condition will become tomorrow's current condition. Additionally, the marketplace and the shop floor are dynamic environments, so improvement must be ongoing. New value stream walks and material and information flow reviews will be necessary to uncover the next round of improvements. When the team is discussing the current condition or possible improvements, input is needed from everyone. Do not rely on a single individual or computer data to make decisions. Remember, the people who do the work are there 100% of the day and will have key observations no one else can provide. Once you do decide to make a change, ask why 5 times to get to the root of the issue. This will ensure you are solving the correct problem for the long term. Within the factory, you can see 3 different types of flow: material flow, production flow, and information flow. Sometimes material is available, but the machine or people needed to process it are not. Other times, people or machines are waiting for parts or information. This out-of-phase condition causes unevenness, peaks and valleys, and instability in the production sequence. Uneven processes cause confusion, delays, and inefficient use of company resources such as people, equipment, and material. During the value stream walk, the team keeps an eye out for any form of non-value-added activity or waste. The 7 types of waste are storage, transportation, waiting, motion, inadequate process, defects, and overproduction. The last waste, overproduction, is the worst waste of all because it amplifies all the other wastes. Learning to see waste is not easy. Value stream mapping provides a good way to document and quantify the effects of accumulated wastes across a value stream. Building a value stream map is a 3-step process. The first step is to draw the current state map. Next, creativity and teamwork is used to map the ideal value stream or future state, which is actually only a small step in the direction of ideal. Then, lastly, an improvement plan is created to get you to the new target condition. The future state map will be used as a tool to reveal the team's improvement vision to others, building support and a common understanding for the proposed new ways of doing business. The symbols of value stream mapping are shown on the back cover of this DVD. Using the symbols is necessary to build a common understanding of a process, current or target. And just like a language, the more you practice with the symbols, the better you will be at using them to communicate. The map will contain different pieces of data and information about the value stream. It is useful to begin by identifying the mix of products being built and to calculate the takt time or rate of customer demand for the overall value stream being studied. For each of the different steps in the value stream, the following information is needed: the length of the typical workday, the number of operators, average daily production volume, takt time, also called the customer demand rate, cycle time of each process step, changeover times, operational availability of machines, days of stock on hand at each step, and scrap rate. As the team walks the value stream, they will actively try to discover and record this information. Simple forms are used to remind them of what needs to be captured for each value stream step. The forms will be used later to build the current state map. In the factory, it's helpful for team members to use Post-it notes to write down issues and opportunities that are uncovered. For example, it's helpful to note any of the 7 types of waste observed, to capture important input from operators, or to identify a safety or ergonomic issue. One person collects the Post-it notes and completed forms from each value stream step before moving on so that they can be analyzed back in the meeting room. It's important to respect the knowledge of the employees on the factory floor since the team is in their workplace. Try to stay out of the way and do more listening than talking. Make sure you tell the workers in advance of the team's shop floor visit and that they understand the purpose of the visit. Ask them to be open and honest about the current state of affairs in their work areas. The high-level map of the entire stream will consist of only major process steps and how they are connected. Encourage the team to move quickly and not get caught up trying to capture every individual operational work step. Most value streams only require a few hours to gather the data, not days. In developing the current state map at Yodel, the team spent less than 4 hours observing the work and clearly understood that a value stream map was to represent a reasonable approximation of how the stove value stream operated on a typical day. Of utmost importance was that the steps were complete and in the correct order, that the data collected was reasonable in the eyes of the workers and team members, and that the map and quantities would make sense to others who viewed the map and knew the process. Now, let's follow the team as they observe the 16 steps of the current stove assembly line. When gathering data for a value stream map, it is best to start at the customer end of the line and work back upstream through the chain of customers and suppliers. For this value stream, this means the shipping area, the last step before customers receive their stoves. Here in shipping, the team observes computers, printers, and the various documents prepared for each shipment. After the paperwork is printed and signed, the employee gets the stove and places it by the shipping door, signs more paperwork, and contacts the shipping company for pickup. The team can already make some observations about movement, weighting, etc. The team's input regarding key metrics and ideas for waste elimination are collected and placed in an envelope. The next step is the warehouse. Yodel is a build-to-stock operation. Stock is stored as a buffer to avoid running out of product, especially during the busy months of their highly seasonal operation. Here, the team gathers data to identify the number of products sitting in finished goods inventory. The team identifies finished goods as a key flow stagnation point for Yodel, with many products waiting for customer order or shipment. Continuing upstream, the next area is the final inspection and packaging station. The team begins by counting the number of stoves in this area. At each workstation, the team asks the workers how many and what types of problems they have on an average day, and what steps could be taken to fix the problems. Some of this information is useful to calculate the percentage of quality problems, potential changeover or operational availability issues at the step. The next operation upstream is the area where the glass is prepared and installed. As with all the areas, cycle times are recorded along with material on hand and key data on activities such as changeover, uptime, and quality issues that take away from value-added work and compromise value stream flow. Another reason it is important to talk to the line workers before the team of observers descends upon them is so that they don't feel the need to work faster or slower than normal just because they're being watched. They should work to a normal pace that they could stay at all day long, every day, so that observed cycle times are realistic and normal. The next upstream step is the gas testing station, where the stoves are fired up and examined for gas leaks. Next, the team observes the installation of the burners, documenting how long it takes and the number of burners stored by the assembly line. Units sitting by the assembly line are a symptom that flow has stopped and possibly that overproduction has occurred. The team asks questions to discover why inventory is at rest and whether the amounts are by design or by chance. The burner assembly station is the next upstream operation. Here the team observes wires being connected, bolts being tightened, and valves being connected. Prior to being assembled, each burner assembly starts with a wiring harness. These wires are cut to length, placed in a plastic conduit, then soldered to a connector. During the walkthrough, it's also important to assess the state of workplace organization and cleanliness, or 5S. Determine if the process areas are being visually controlled to discover problems or interruptions quickly and easily. For example, as the team members continue up the value stream, they take note of additional material stored next to the assembly line. In one case, they find a bin of materials clearly marked. However, once the bin is removed from its location, there is no indication of where it should be stored. Marking both the bin and the location contributes to fewer mistakes and less time searching for parts. Prior to assembly, some parts of the stove are painted black. While the team observes the painting operation, they noticed some small parts leaning on a crate. This small makeshift storage area tells the observers the painter feels the regular storage of these parts is too far away from him. This information is important to record and represents another improvement opportunity. In the paint area, changeovers take about 10 minutes for a different paint and about 5 minutes to have new components delivered. While this sounds like a quick changeover, any time spent doing this is a waste and may be a target for improvement. To keep the painter painting and not looking for parts, Yodel delivers a kit of sheet metal parts on a cart directly to the line. This cart contains every sheet metal part needed to build a total of 35 stoves. This cart system is a good example of how Yodel uses a Kanban system in some areas to pull work through the plant and control how much inventory can be made by the upstream process. Once the 4 carts are full, the operations that make this material have to stop and wait until they receive an empty cart before building more parts. Upstream from paint is the firebox assembly area. Here, sheet metal is assembled and placed inside the stove. While there, the team sees dozens of extra fireboxes sitting on the assembly line. This extra inventory raises a red flag for the group and brings up questions aimed at finding the reason for the extra fireboxes. As it turns out, they were built to buffer an upstream changeover in welding as well as a difference in shift work times. Next, the team watches the drill and tap operation within the cast iron assembly station. Here the team observed excessive movement as the worker performed his machining and assembly steps. The cast iron for Jodel stoves is supplied from the parent company in Norway. These wooden crates are filled with all the various cast iron parts needed to assemble stoves. Because much of the cast iron parts are already coated with colored enamel, Jodel keeps a wide variety of color and styles on hand to meet customer demand. This amount of inventory has proven necessary due to slow delivery times for these exceptionally heavy parts. But even with these issues, Jodel still sees the value of working to reduce the amount of stagnant inventory. All of the internal fireboxes of a Jodel stove are built with welded sheet metal construction. The welding process is done with a combination of robotic and manual operations. While most of the steps in the stove assembly process can be finished in about 8 minutes, the firebox welding can take from 10 to 20 minutes depending on the style of stove. To keep up with the rest of the factory, the welding department is currently working 2 shifts to meet demand. The sheet metal used to build the firebox comes from several new machines. Jodel has purchased sheet metal press brakes to make the wide variety of bends required for each unit. A laser trims parts to final size, and a punch press cuts the sheet stock to size and makes the required holes in the material. There have been successful efforts to reduce changeover activities on this equipment, resulting in enhanced flow and reduced batch sizes. However, the team recognizes that equipment changeover is non-value added and represents a key reason Jodel cannot currently produce one at a time in some areas. Right after the team finishes their observations, they return to the meeting room and start drawing the current condition value stream map using the data gathered from the value stream walk. While it may sound like there are some problems with the manufacturing system at Jodel, the overall system is currently very productive, making over 65 stoves every day. It's important to note that a value stream mapping exercise should point out the good things or best practices as well as the improvement opportunities. Perhaps these best practices can be spread to other parts of the value stream in the target condition. The current state map is made up of a series of boxes, each representing a major value stream step in the manufacturing process, with the customer on the right side and the supplier on the left side. Next, arrows are drawn to indicate how the major process blocks are connected to one another. In Jodel's case, several arrows with vertical lines are shown between some of the boxes. This indicates a push system of production rather than a pull system triggered by actual need of the internal customer. The striped arrow indicates a bad condition, one that causes material stagnation. For each step in the process, they recorded how much time was spent adding value. These cycle times were then added up to come up with the total value-added time it takes for one stove to go through the system or to be transformed from raw materials into a finished stove. It took 131 minutes of overall stove assembly and 160 minutes to build the internal firebox, a total of 291 minutes of cycle time to build a stove. Then, they calculated how much stagnation time was in the current value stream by translating the amount of material queued in the value stream into its corresponding amount of time. This is done by multiplying the quantity or parts counted in an area by the takt time. Some manufacturers refer to these queues as WIP, work in process, but a lean thinker will see this as stagnation. For example, if 50 fireboxes were found in an area and the customer needs a firebox every 20 minutes, takt time, then the 50 fireboxes are the equivalent of 1,000 minutes of time. By adding up the amount of cues sitting in front of each step, the team could see how much stagnation was built into the current condition value stream. The total amount of stagnation time across the value stream was calculated by the team as 485 minutes. To arrive at the overall production lead time of 776 minutes for the stove assembly process, the team added the total cycle time for a stove, 291 minutes, to the total stagnation time, which in our example is 485. This number is a key outcome from the current state mapping exercise. It is important for the team to determine what portion of the expected time a product will be in the Yodel value stream is really time the customer is willing to pay for. All the other time, waiting or stagnation, should be a target for improvement and be reduced or eliminated over time. Next, the team maps out and discusses the information flow for stove production, or how instructions are given to Yodel employees and suppliers about what to make or provide and when. This includes discussions on how raw material is currently ordered and supplied. The Yodel team noted that because the parent company is in Norway, it does actually send a boatload of inventory when shipping cast iron parts for the stove to the Gorham main site. For the rest of the parts, the team discusses the current method of production planning and how the monthly forecasting and MRP system drives the current ordering and production process. It's also determined as to whether the systems are push or pull in nature. At the end of the first day, the map of the current state is finished, and the team is in agreement that it is a reasonable representation of how the stove value stream operates today. Everyone on the team acknowledges that they learned a lot from observing the actual work being performed. They were surprised at how many parts were being moved twice, once to the line side storage area and then again to where it is convenient for the worker. Also, even though Yodel had invested in ergonomic lift tables, the team was surprised to see how many workers were still doing work that looked difficult or prone to injury. In mapping the current state, they wrote up many post-it notes about areas that could use immediate improvement. The simple and easy ideas could be implemented right away. Other ideas that might not be immediately implementable would be discussed and considered for incorporation into the future state map, which would be drawn on the second day of the mapping session. The next morning, the team went through the groups of post-it notes collected at the 16 process steps. As they looked at these notes, they assessed each situation by discussing any bottlenecks or flow-related problems observed. They were also focusing on the striped arrows, or places where inventory was being pushed, not pulled through the system. After examining all of the current state information gathered from observation of the assembly line, the team needed to boil everything down into a summary of the biggest problems. This step helped the team reach agreement on the areas to focus on for the target condition mapping exercise. For Yodel, one opportunity the team uncovered was to use better visual controls to tell where things should be stored and how many should be there. They also felt a better layout of the assembly line would help reduce excessive walking. Other waste they observed was too much inventory stored on the line and the length of time it took to change over to a new part for different model stoves. One issue Pat observed was the lack of work standards posted at the workstation. For example, a new employee had time to make a few extra valves since she had worked faster than normal on previous stoves. It would be less wasteful to use the extra time to clean the work area or train with an upstream or downstream team member. This is an example of overproduction. Standardized work instructions posted at the work area minimize the likelihood that operators will finish early by establishing work time standards and define acceptable levels of WIP inventory. Pat also made a suggestion about having a better defined material handling function for parts staged by the assembly line. This would keep the assembly people doing value-added work instead of searching for materials. The results of this problem are the wastes of inventory stagnation, batching, walking, and searching. Now that they can see and quantify the current state using the value stream map, the team spends some time considering what the ideal condition will look like for the stove value stream. They are reminded to strive for a pull system, with frequent withdrawal of materials, minimal WIP and supporting inventories, and the most effective use of operators and equipment. All the processes are to be connected and synchronized according to customer needs. Every time a stove is sold, this information is fed back through the value stream to cause material to flow through the production transformation processes. The ideal condition is also to be flexible enough to build every stove every day in lot sizes of 1. Now that the team has an understanding of the ideal condition, they are challenged by Pat to come up with a target condition that is a step in the direction of ideal. This new future state map will show the best practical condition the team believes can be reached by the targeted date. The target date should not be 1 to 2 years down the road, but a plan that can be achieved in 6 months or less. As part of drawing the target condition map, the team will identify the areas where Kaizen activities are needed to reach the improved state. Identify key measures required for success. Prioritize each improvement, and establish a time frame for completion. The future state map for this value stream was drawn with only 6 steps in the process, significantly less than the original 16. This reflects the changes proposed, which would combine many of the distinct assembly operations. The largest improvement would be changing from having 6 workstations that do electrical assembly, valve assembly, pilot assembly, burner assembly, glass assembly, and final packing, to a single final assembly and packing area. This will require a sizable amount of work to plan for the most productive use of the materials and workers needed in this space. As the discussion continues, the team focuses on the system used to communicate production scheduling. They propose moving from push to pull and introducing a set number of Kanban cards each morning for each stove built that day. These cards will represent requirements for customers and maintain the varying stock levels necessary to handle Yodel's highly seasonal demand. The team proposes sending customer information to only one point in the process, the warehouse. Using a pick ticket, the warehouse will ship the order. After shipping, the Kanban card, which is to be stored with each stove, will be returned to the planner. The planner reissues the Kanban cards into the production process as needed to cover demand. By lowering the number of Kanban cards in the system in the slow season, there is control over the number of stoves being built. Then in the busy season, more cards are added to meet higher demand. Overall, the value stream will be pulling work through the plant, and the final assembly area will be set up as the pacemaker of the pull process. A daily rate of production will be agreed upon between planning and the plant for a month-long period. The team discusses breaking the daily rate down into hourly buckets and recording output each hour at the end of final assembly. This will give workers an understanding of even flow and a means to quickly tell everyone when the customer pace is being missed. After some additional planning, the team comes up with a list of projects or Kaizen events needed to get Yodel to the future state. This list includes changes like setting up a Kanban card system for each day's production, changing to a true pull system internally and with key suppliers instead of sending purchase orders, combining multiple assembly areas into one assembly cell, and standardizing the material handling operations so they do not interfere with the value-added work. Along with these plans, the team has established dates for the completion of each of these projects. This timeline is necessary to make sure the work gets completed despite the daily work of building and shipping stoves. A timeline is also important to selling the plan to upper management, since resources will be needed to make the proposed changes. After coming up with the plan, the improvements are quantified in terms of quality, cost, lead time, and flexibility. The management teams need to know what to expect after all the work is accomplished. A perfect tool for summarizing this is an A3 diagram. The A3 diagram has 4 key elements: the background information and a current state map in the upper left. Below that is a list of problems the team has found with the current state and what the consequences are of those problems. In the upper right, it has a future state map and a list of the key countermeasures and their anticipated effects on the value stream. Below that is a plan which includes milestones and a timeline for accomplishing the future state, as well as key before and after measures. The A3 diagram is a simple and easy tool for making the case for value stream changes. It can also be helpful for measuring progress and keeping the future state project on track. Value stream mapping is an important continuous improvement tool, one that helps us step back and understand the series of steps, both value-added and non-value-added, necessary to satisfy customers. It is a critical go-see method that engages the team as they learn how to document and quantify material and information flows. It is a springboard pointing to opportunities for improvement. Like the continuous improvement system it is a part of, value stream mapping is meant to be an iterative process, moving from current state to future state to current state to future state. And it reflects the Kaizen spirit, concentrating on changes that can be made now to take a step in the direction of perfection or toward that ideal state. And like Kaizen, the only way to get good at value stream mapping is to go see and practice. We asked Scott Clinch, manufacturing manager, what he experienced during the mapping process.
We get so involved in our day-to-day that we don't see, we walk right by the opportunities. And this certainly sheds a light on it. And I think what helps too is having the entire team together as far as people from different departments, because they come into it without any preconceptions or probably not knowing much about what really goes on in that department, and can see things that we would never see, or ask questions that we'd never ask.
Next, Brett Watson, president of Yodel North America, shared what he was hoping to take away from the event.
The immediate takeaway is we thought we were good, but we've got a long way to go. And, it took Toyota dozens of years to get to where they are now. And any company that embarks in lean manufacturing, it's a journey. And we're in year 7, but really what came about yesterday is we're really in year 2 of really being serious about lean with a pull system that we thought was a pull system, but it actually is still a push system.
Brett also saw some things that reminded him of how important it is to treat every employee as a customer.
Anything that they were doing that we didn't think was being done right is a direct result of us not treating them like a customer, or training them, or giving them an education on sort of the best way of doing things, from an engineering standpoint, from a material standpoint. We just, again, the awareness, the most enlightening part is the awareness of making sure that our customer has everything at his disposal on the line to build our products.
This is 90% about people, and if you aren't out engaged with the people, then you don't really appreciate what happens every day. And also, I truly believe that they work extremely hard, very often under conditions that are less than optimal, and they do a heck of a job despite all the little interruptions, disruptions, issues that occur every day.